Okay. Okay, so Lena's looking for page 128, number 20 here. So that's the hovercraft question. So with this question here, we have ourselves this hovercraft, right? This is 128, number 20. And we have this hovercraft, and what do they tell us in the question is that it goes 40 kilometers an hour. That's over flat land. And then it has a different speed, a slower speed at 10 kilometers an hour, and that's over rough water. So over water, it's going much slower. And then they told us the total trip is 185 kilometers. So in this question here, they want us to find how far did it travel by land and how far did it travel by water. So like we had talked about, you can introduce your variables. I can let L be the distance traveled by land, and I can let W equal the distance that I traveled by water. So you can start off with defining those variables there. Now the problem people have is this part's easy. I know that the total trip is 185 kilometers. So I know that the total distance by land plus the total distance by water is 185. The second equation is where people have trouble because they tell us in the question, one other piece of information, they tell us that the trip took 5.75 hours. So we were told in the question that the trip itself took 5.75 hours. So my variables are in terms of distance, but I have to express them now in terms of time. So what you have to do here, Lena, and please let me know if you understand this or not, is you have to take your length, in this case the distance you traveled by land, and divide that by your speed. Because if you take distance and you divide by speed, you get time. And that's what I'm using here. We didn't really come across that in the homework. The homework questions were mostly speed times time is distance. Like we actually were multiplying these two together to get distance. But in this case here, we have to do distance divided by speed is your time, plus the distance divided by speed is, this is the time by water. Right, this will be the time I spent on water. Lena, does that make sense? Like this is the time I spent by land, and this is the time I spent by water. So when you sum that together, you get the total time. You get the total time, which is 5.75. Okay, good so far. So let me know if there's any questions. So now that I have that, I go to solve this here. So you can solve using substitution if you want to. So in this case, I'll isolate for L. And I can sub that into our other equation here. Sure. So I'll take the 185 divided by W. Is this okay, Lena? You see the step here? Okay. All right, good. So solve for this here. You can multiply across by 40. in which case I get 185 minus W plus 4W, and then 40 times 5.75. Sure thing. Okay, we'll finish off. Let me finish off this one here for Lena, just to make sure we talked about it. So I get 185 plus 3W is 40 times 5.75 is 230. So 3W. You end up getting 45, and I get W is 15 here. So your W is 15. That would be the distance by water is 15. In this case, this is measured in kilometers, so 15 kilometers. And then therefore your distance by land is 185 minus 15. I believe, yep, 185 minus 15, and that gives you your 170 here. Okay, I'll just kind of go through these questions in order. We've got number 13 here. Sure, I'll get to all those. Right, number 13, sure. So this will save to Lena, so you'll be able to re-watch it like when we're done this stream here. Let's take a look at number 13. This is from the worksheets. Do I have the worksheets? Okay, so number 13, and the person who asked that, if you could let me know, is this correct here? Was this the question you're referring to? You have the 5% mixture, and then you have a 9% mixture, and you want 3 liters at 8% concentration? Excuse me, was that the question? Whoever had asked for that? Okay, so for this number 13 that was being asked, this is a mixture question. You'll probably see one of these on tomorrow's test, just so you know. So in this case here, we had kind of talked about this before, but this is your X. Yeah, no, I know that. Yeah, this is it. Oh, I see. She has 5%. Okay, good. Thanks. So for this one here, if we're going to do this one, they tell you two things. X and Y is the amount of liters of each. I know I need to have X plus Y is 3. And since you said you're just looking to solve it, I'll bet you have 5x plus 0.09y is 0.08 times 3. So this is an ideal substitution question. So right away, I'm going to let x, in this case, equal 3 minus y. Oops, sorry. I'll let x equal 3 minus y. And I can sub that into my other equation here. So this will be 0.05. I can get rid of this x and change it to a 3 minus y plus 0.09y is going to be 0.24. Right? Don't forget 0.08 times 3 is 0.24. So end up getting here 0.15 minus 0.05y plus 0.09y is 0.24. And we end up getting here 0.15 plus 0.04y. So just kind of going through and crunching these numbers here. You should have got here, if I'm talking to Michael, we get, or Matthew, 0.15, get 0.09. So if I divide this out, I am getting here 0.09 divided by 0.04 is the same thing as taking 3 divided by 2, and I'm getting 2 1/4 or 2.25. For my y value. Let me kind of move that over. Once I got this y value, you know that it has to sum to be 3. So if I sub it back up top in 1, you end up getting 3 here. So my x value is 0.75. The reason that I multiplied by, the reason I did this right here is because this is giving you, like when you multiply these two values together, this is just the saline in the mixture. This is just the saline in the mixture. The 8%, if you just put 0.08 or just put 3, then you're either just, if you just put 3, you're talking about everything, the entire 3 liters, including the saline and water. If you put 0.08, you're just talking about 8%, but 8% of what? It's 8% of your 3 liter mixture. So you have to kind of multiply the two together to get that. Okay, good. All right, next here, boom, boom. And then Dalal wants number 14 from the worksheet. What was 14? Actually, I can load it up. Let me see. Oh, 14 was the car. Oh, we did not take up 14. Okay, so for number 14 here, let me just jot it out. You've got a car that gets 9 liters per 100 kilometer in the city, and then it gets 7 liters per 100 kilometer on the highway. And you know that a 720 kilometer trip, you used up 55.7 liters. How far did you drive in the city, and how far was the car driven on the highway, and how much fuel did it use when driving on the highway? Okay. Hello. Are we good here so far? All right. Dalal, are you with me here? So for number 14 here, you've got a car, it's driving different things, right? Like if you're, thanks Dalal. So in the city here, you're going to use up more gas. So you're eating up 9 liters per 100 kilometer, whereas in the highway, you're highway driving, you're accelerating less, in which case you're using less liters per 100 kilometer. So you know in this question here that you go on this trip, and 720 kilometer trip eats up 55.7 liters. So the idea here is what you want to do is set up an equation to solve this. So in this case here, you can let, let's see, I can let x be the distance driven by the city, and I can let y be the distance driven by on the highway. So you can partition this up into distance by city and distance by highway. All right, good. So continuing on with this here, you know that the total trip for this, if you go to look here, your total trip is going to be 720 kilometers. So if you put, here's the problem, if you put x plus y, for instance, is 720, like if you go ahead and, for sure, Mina, for sure. If you do x plus y equals 720, then you've got your distance by city and distance by highway comes out to 720. For part 2, though, you want to talk about how much gas did you use. So if I take x and divide it by 100, like what you're getting when you do x divided by 100, you're getting the how many chunks of 100 kilometers get used up. So if I multiply that by 9, then that represents how many liters of gas I'm going to use up. See, because the idea here is for every 100 kilometers, you're going to use up 9 liters. So like for instance, if you end up driving, let's say you end up driving like 500 kilometers, right? Then you're going to divide that by 100, in which case that's 5. So it's going to be 9 times 5 gives you your 45 liters of gas that you use up. See, the idea with this one is every 100 kilometers that you drive, it costs you 9 liters of gas in the city. So if you take the total number of kilometers that you have driven and divide by 100, then you end up multiplying that by 9 for the total liters of gas, right? And then likewise here, if you do 7, take your total distance driven divided by 100, that'll give you the amount of liters of gas that you use in the highway, and that's equal to 55.7. Does that make sense, Lena? Or who's I talking to? Actually, Dalal? Oh, yeah, excellent, Dalal. Exactly. Yeah, you got it, for sure. Yep, and then you can reduce that to be 0.0x plus, yeah, very good. Plus 0.07y is 55.7. Do you want me to solve it now? Sure. All right, all right. Okay, here's 14. We're good. All right. Let's continue here. I've got, this is done, this is done. Okay, I've got page 137, number 8. Page 137, number 8. Okay, this one here, page 137, number 8, it's a similar idea. What you got here is gas sells for 78.9 cents per liter. This is premium gas. And the regular gas is $71.90 per liter. And this is your regular gas here. Regular gas. And it says to boost sales, middle octane gas is formed by mixing. So this is sort of like a mixture question. If you look at something like this, so if we take a look here, this question here, I'm not sure who had asked it, but this is like a mixture question where we're mixing these two sort of types of gas together. I've got this one and I've got this one, and I'm mixing them together in such a way that the cost is $73.9 cents per liter, and I need exactly 1,000 liters of this gas. So this one here is actually a mixture question, but instead of being a concentration level question, it's broken up into like a certain price per question. All right, so continuing here, if we take a look and I go to solve this, I can mix this together with two different variables. So I can let P be my premium gas, I can let R be the regular gas. Right away I know the premium gas plus the regular gas adds up to be 1,000. And my second equation, I want to now get this price here. I want to go ahead and get this price to come out. So you're going to take the 78.9 cost and you multiply it by the number of liters, right? Plus you take the 71.9 regular and then you go ahead and multiply that out by your regular amount. So if you take a look here, this is the total cost. You see, this will be the total cost of the gas per liter. So I multiply that by P, and this is the total cost of the gas per times my regular one. Sorry guys, I keep having to get this guy out here. I'll have to set up our next help session just as a private session, because obviously people are like jumping on here and I'm having trouble getting to my students' comments here. Who asked this one? Like, who am I working on with this one? So this is going to end up being 1,000. Alvina, okay, thanks, Alvina. Eka. Okay. So Eka, this will be 1,000, and you multiply this by the cost that you want, which is $73.9 cents per liter. Is this okay? All right. Yeah, that's fine. Just wanted to know who I'm kind of speaking with this one. Sure. Let me just make sure I didn't miss someone else's question. I think we took care of these ones. Dalal's good. Sir, can you go over the difference between time, speed, and distance? For sure. The basic idea is your distance, in this case distance, and the way we worked on it was is equal to your speed times your time. So if distance is equal to speed times time. But we looked at questions where you have to take your distance, and you can manipulate this formula anywhere you want. Some of you guys in science would have already seen this d equals s times t. Like, you have this formula to work with, obviously. But we also have the idea that distance divided by speed is also equal to time. So you can manipulate the formula just by dividing things out here. So d over s equals time. And we saw that in the question that Dalal had asked. If you take a look here, if I go all the way up to the first question we looked at was this one right here. Lena had asked this one, the hovercraft question. I had to do that. I had to take if you take a look here, I had to take my distance and I had to divide it by my speed here to get time. So I had to go ahead and divide that out, distance divided by speed, to get the time. So sometimes you have to manipulate the formula a bit to get that to work. A lot of the questions that we were looking at, we were kind of focusing just on this. Distance equals speed times time. And we were solving it that way. Is this all right? Okay. Yeah, that's all. I mean, those are the two sort of variations on it. Did I miss any questions? I was having trouble because there was just people blasting the thread here. So I couldn't get to the questions. But are there any others that I can go through? I'm not sure where people are at here. I can put some questions for you to try if you like as well. I know some people had asked for that. Is there anything specific? Oh, you can hide the comments just for myself. All right. You guys are looking for some more questions. Okay. Let me see if I can throw some on for you. Sure, 137, number 6, sure. Yeah, actually, let's take a look at that one. This is page 137, number 6. So on page 137, number 6, you've got a helicopter finds a tailwind with a 120-kilometer trip away from the airport in 30 minutes. So we've got a helicopter, all right, and in this page 137, you know that when it's going with the it says it finds a tailwind, so it's essentially saying when it goes with the wind in this question. This is page 137, number 6. It says when it goes with the wind, it can do 120 kilometers in 30 minutes. And then I know that same helicopter, when it's going against the wind, obviously the distance of the trip hasn't changed. Number 8. Yeah, I've already done, I did number 8 already, so it'll be in the stream when you check it out, whoever is asking that one. But for 137, number 6, the general idea is I can do this in 10 minutes longer, so it takes 40 minutes. So who asked this one, you know that when I'm going with the wind, the helicopter speed plus the wind is going to be 120 divided by 30. Now, the thing is when you get your answer here, if you did this, the answer here is going to be this is in kilometers a minute, right? Because don't forget you're dividing by 30. So I don't know if the back of the book gives the answers in hours, in which case you have to multiply by, in which case you have to multiply by 60. For the second equation, you're going to take speed of the helicopter minus the wind is 120 divided by 40 is 3 kilometers a minute. Rima, the reason I divided is because the question is talking about speed, right? So I'm letting here h be the speed of the helicopter. So this is the speed of a helicopter in kilometers. This is in kilometers a minute. Or actually, I think the answer they wanted, well, this is in kilometers a minute. And then I'm going to let W equal the speed of the helicopter in kilometers a minute. So, yeah, exactly. So when you do all your math here and solve, see, the idea here, Rima, is this is an idea of speed, this is idea of speed, and this is back to what was asked earlier. If I take distance and divide it by time, if I take distance and I'm dividing by my speed, by time, by time, I actually get my speed here, right? So this is back to the, what was asked earlier. This is another variation on the formula. D over T is your speed that you go at. So I'm using this, I'm using this formula here. Is this good? So now I can go ahead and do these calculations. Rima, does that make sense? Okay. So you had to go ahead and divide it out. Now when you go to solve this, watch what happens when you go to solve this. You can solve this using elimination or substitution. I'll just add these together and it cancels off the W's. I get 2h is 7, in which case h is going to be 3.5. But that's measured in kilometers a minute. So if I multiply that by 60, that'll be the answer in the back of the book. I think some people had messaged me that before, that it was in kilometers an hour. Okay, so if I multiply that by 60, then we're good. So I don't know what answers they have there, but if I take 3.5 and multiply it by 60, was the answer 210 kilometers an hour for the helicopter? No, not yet, guys. Not yet. We got to do this first. No COD yet. Oh, Lena, the reason I did 2H is I'm adding these equations. I chose to add them, so I canceled the W's. I got 2H is equal to 7. Is that good? So I got 2H is equal to 7. If you want to, Lena, what you can do is you could have we could have subtracted instead. Like, just to show you, take this equation here. Just to show you, Lena, since you asked. Let's take this equation, and I'm going to subtract these. If I subtract these, we cancel the h's this time, and I'll get 2w equals 1, in which case I get w equals 0.5. Right? Is that okay? So I get w equals 0.5. This is in kilometers a minute. So if I multiply that by 60, you end up getting 30 kilometers an hour. So you can solve it either way. I got 210 for the helicopter and 30 for the actual like tailwind speed. Is this okay? We are good? How did I get rid of the fractions? Rima, did you mean how did I go from 0.5 to 30? Yeah, so Rima, the idea here is I divided by 30 minutes. So this answer was in kilometers a minute, but the back of the book is giving the answers in kilometers an hour. Is that okay? Infinite. Okay. All right, I got some questions for interest. I see some people are asking interest questions. I can make one up if there's not one from the textbook. I can find one if you want. I know, Mina, I'm looking here a second to try to find some. So if you did set this up, you could let P equal Paula's age. Okay, now, and I'm letting B equal Bob's age now. So that's like a good way to start it off, right? The question is asking for how old are they now, so let P equal Paula's age now, and B is Bob's age now. So in this question here, it said Paula is 12 years older than her brother. 4 years from now, Paula will be two-thirds. How old are they now? So equation 1 is definitely Paula is 12 years older than her brother. So Paula's age is her brother's age plus 12. Does anyone have the second equation? Because I can see Rima got the first equation right, and Mina's got 2/3 P equals Bob plus 4. Now it says 4 years from now. So 4 years from now, all of them will be 4 years older now. So 4 years from now, Bob will be 2/3 as old as Paula. So in 4 years, Bob will be 4 years older. And at that point, he'll be 2/3. So 2/3 as old as Paula. So 2/3 as old as Paula would be 2/3 P plus 4. Yeah, there you go. Good. Very good. Is this okay? Yes. But Mina forgot the p plus 4 on the p variable, is what Mina forgot. But that's still very close. You got to put brackets around it because it's the age that's being referenced. The age that's being referenced is 4 years from now. So this 2/3 factor is 4 years from now. So in other words, the idea is that in 4 years, Bob will be 4 years older, and in 4 years, Paula will also be 4 years older. But you know that you have to add 4 to both because they say right here it's 4 years from now. So if P and B represent Paula and Bob's current age, like today, in 4 years they're going to both be 4 years older, and then in those 4 years, Bob will be 2/3 Paula's age. So in other words, Bob's future age in 4 years is equal to 2/3 Paula's future age in 4 years. So you have to add those P and 4 to both variables for this one. Do you want to try another one like this? Would you like to try another age question? I've got another one below. Okay, let's try another. So it's got Carlos is 8 years older than Maria. And then it says 4 years from now, Bob. 4 years from now, not Bob. Sorry, that's the wrong question. Carlos is 8 years older than Maria. 4 years. Wrong. 4 years, not from now. 4 years ago, Maria was 2/3 as old as Carlos. And they want to know how old are they now. Thanks, Rima. All right, I'll let you guys try out this one. Give this one a shot and see how you do. Okay, let me know when you have your equations. Obviously, you're going to let C equal. Yeah, like C is going to be Carlos's current age. And then M is going to be Maria's current age. So if I set up my equations here, so Carlos's current age is 8 years older than Maria. So that's easy. Now the second equation says 4 years ago. Yeah, very good. 4 years ago, Maria was two-thirds as old as Carlos. So 4 years ago, Maria, so Maria's age 4 years ago is m minus 4, was two-thirds as old as Carlos. Yeah, you got it. Very good. Rima's got it. And other people as well. Avogadro more got it too. Okay, is this good? Okay, I've got another one here that might be useful. This is a plain question. A mighty foot 21 is Omer. Good to know. A train leaves the station and travel. Oh, sorry. Two planes travel toward each other from cities that are 780 kilometers apart at speeds of 190 and 200 kilometers an hour. I'm looking. I'm looking. Okay. Interesting. Interesting. Oh, you're welcome. Um, so I'll make up a question here for Marie. Here's an interest one. I just kind of made this up. We can do this one. Okay, here's two examples. Here's an interest one. You guys, I'm hearing a lot of people want that. So let me just convert this to text so you can read it. Okay, this is probably a bit. Oh, I didn't even take up the plain one yet, but I can take it up. You guys really wanted this interest question, so I made one up. Okay. The plain one, did anyone look at the plain one yet? Or want to try the plain one? Sure. So the plain one's a bit weird. It might be too difficult. Let's go through it together and see. Okay. So you've got this plane. So we have these two planes. They're 780 kilometers apart. One plane can go 190 kilometers an hour. The other plane can go 200 kilometers an hour. You know that you want to know when they meet. So, yeah, it's a bit confusing, this one here. But if you read the question, if you let t be time, I don't think I'll ask this on the test, actually. I'm going to let t be time in hours. So maybe shouldn't have asked it. If you let t be time in hours, you know that this plane here is traveling 190 t. Right? That's the distance. This represents, if I take 190 times t, that's the distance that this plane is traveling over time. And 200 t would represent the distance that this plane is traveling over time. Well, there's only one equation, actually. You take 190 t plus 200 t, that has to equal 780. There's only one equation, you just solve for t. So I wouldn't ask this on the test because it's a little bit confusing. But that's the idea. Well, the thing is time is running continuously, right? So they leave at the exact same time. So what happens is after an hour, this plane has traveled 190 kilometers. After 2 hours, it's 380 kilometers, and it keeps going. After 1 hour, this plane is 200, then 400, then 600. So the thing is once the sum of their distances equals 780, which is their distance apart, they must meet, right? Like when these two lines actually cross, like if you think about it, when these two arrows, let me draw it in red, when these two things actually cross here and like meet one another, like that, when that happens, the sum of this plus the sum of this has to equal your 780. Right? And that's the idea with this one. But I won't put this on the test just because it's a little off to what we've been doing, but that's the idea with this one. So you would just actually solve this equation, just one variable, and be done. Okay, I'll let you guys try this one if you like. Subtract them and take the absolute value. Fancy. No, you just add them, and then once you add these up, it has to equal 780. Because once it equals 780, they would cross. Right? Eventually, when these two planes meet, the sum of their distances must be 780. It can't be any less, and it can't be any more. If it was more, that means they already passed each other by. If it was less, then they haven't. So it just has to equal 780 right on. But here, try an interest question. You guys have been asking me about the interest question here. So this is Marie looking to invest $5,000. Part is in a GETC at 6%. The other is in a mutual fund at 11%. If she makes, so they tell you that she makes twice as much interest on her GIC as her mutual fund. How much did she invest in each? Okay, just set up the equations. I made this question up so the numbers could be messy. But if you set up the equations, you can check to see whether you did it correctly or not. Okay, so Rima, when you're answering this question, it says, how much did she invest in each? So right away, those are your variables. You're going to let G equal the amount in the GIC and let M equal the amount in your mutual fund. Right? That seems pretty straightforward. Is this okay so far? Okay, so I think, do you guys agree equation 1 is G plus M is 5,000? And Marie, since you had asked it, were you able to answer the second equation? How do I say that? Yes, we are too, we are too good. All right. So the next one says if she makes twice as much interest on her GIC. So how do you write the interest on the GIC? The GIC is 6%. So this right here is the interest on the GIC. So the interest that Marie made on the GIC is equal to twice the interest that Marie made on the mutual fund. Did you guys get that equation? Mina and Dalal celebrated far too soon. Yes. Far too soon. Interest on the mutual fund. Oh, did you got what I have here, Dalal? If you did, that's great. Because it's a little bit different, right? I had just made it up, but that's the idea. Yep, very good. Gurman, you just got it backwards. The 2 should be on the 11, the 11%, because it says you made twice as much interest on your GIC. So the interest on your GSA is larger. You have to take the interest you made in your mutual fund and double it. Oh, okay. I think Gurman got it though. It's very good. Is there ever a different equation you can make? These are the only, yeah, that's about it when you're solving these. Percentages? Like, why aren't they percents? Well, if you want to write them as percentages, then you have to, like, if you do like 50% of something, you usually convert that to a decimal place to take the amount, right? Because, like, let's say you have $100, Mina, and someone says you owe me 10%. You're not going to say, okay, 10 times 100, that's $1,000 I owe you, right? This doesn't make any sense. right? If you have $100 and someone says, okay, you owe me 10% of that, 10% of $100 is is 10% of 100 is 10, right? So typically what you do is you convert the percentage, which is 10%, to a decimal place, which is 0.10. So this would be 0.10 times your, in this case, 100, which is 10, which is the correct answer. You always convert percentages to decimal places, so divide them by 100. I did put 0.06g. It's right here. Oh, I see. The reason it's not that's a good question. If I wrote this down, if I wrote 0.06g plus 0.11y equals whatever, what this is this is just the interest, and this is just the interest. So this is saying the interest I made on my mutual fund plus the interest I made on my, this is the interest on my GIC, just the interest. And this is just the interest, right? It's not equal to 5,000 because 5,000 is everything. 5,000 represents like your initial investment amount, right? This is your initial investment amount. Your interest is on top of your 5,000, right? Like if I have, let's say I have $5,000, and let's say I put everything into the GIC. If I put everything into the GIC, you multiply by 0.06, right? In which case, you're going to end up getting here your $300, right? That's just your interest. Right? That's just your interest. So that's not, has nothing to do with your initial lump sum that you started off with. It's just the money you made. In total, you have $5,300 afterwards when it's all done. Right? But this isn't what happened here. Marie had $5,000 and put it initially. This is your initial amount you invested in each adds to 5,000, but then you made some interest on it at the end of the year. You're calculating. Yeah, this can be on. We've done a lot of interest questions, so definitely this one's, we did ones where they made the same interest and we equated them. We did ones where you made $43 less, $45 more, stuff like that. I haven't solved the question, but Marie has $5,000 to invest. Okay, are there any other questions? The test is out of, I think, 35. Another interest one? Sure. All right. Okay, is this all right? Can oh yes. Oh, I got yes, yes, there you are. Okay, do you want to try this one? This should be good. Would anyone like? I'll let you guys try this one. So this is Rima, $500 to invest. Oh, so you can set up your equations for this one. You got it, Rima. You got it as well. This is point. The GIC is only 3%, but I know I made $100 more than what was made in the mutual fund. There we go. Is that all right? Very good, very good, very good. She made $100 more interest in the GIC. Yes, we'd have to actually solve it to see what the specific amounts are that are invested, but this is the idea. And yes, Lena, the questions will be like the same style as those 17 that I had asked you for homework. Okay, is there anything else I can help you with before we end this help session? Good, good, good. Marie wants to know how many problems are on the test. Like exactly what I said in class. You've got a substitution question, an elimination question. I gave you two questions. Try any method. There's the what type of solution do you have? Unique, infinite, or no solution, and like those types. And then there are, I think, 3 word problems, but I think I make you solve all 3 completely. Sure. Page 131, number 23. Sure, sure, sure. So Gurman, page 131, number 23, if you look at that question there, that's just like like the barb running in the wind and the airplane in the wind. It's the same idea. The only difference is they already gave you the speed. So you know that in number 23, if K is the kayak speed and C is the current, I'll let K and C be those variables. I know that when I'm going downstream, the current's going in my favor. I know when I sum those forces, it comes up to 26, but they already gave me the speed. I didn't have to divide it out. I didn't have to do distance divided by time to get the speed. I already have the speed. They gave it to me in the question. It's 26. And when I'm going against the current, you're going to subtract the two, in which case you get 6. So when I'm going against the current, it's going to be K minus C is 6. So what is different about this question is they've given you the speed directly, whereas the questions that we did earlier, I had to divide them out. Like the one that comes to mind is the one we did all the way over here. The helicopter in the wind one, I had done page 137, number 6. We had to divide it out to get our speeds. And we do not have to do that here because they gave us the speed directly. Is that okay, Gurman? And then you can solve easily however you like. Right, you can subtract. So C is 10 and K is 16.